Welcome to Aristomath. In this video, we shall consider change of subject of relations. In a relation, y equal to mx plus c. Y is said to be the subject of this relation. We can also rearrange so that a different letter m, x, or c become the subject of this relation. The process is what is termed as changing the subject of the relation. Now let's look at the process to make a letter becomes a subject of a relation. Let's take our first example. Make m the subject of the relation. We have the relation to be mt plus n equal to mp plus q. To make m the subject of this relation, we first group the terms containing m at one side of the equation. So there's m here, there's m here. So we group these terms at one side of the equation. So we have mt, this one is crossing, so we subtract it from this one to become minus mp equal to q minus n. We subtract n from the q. Now there's m here, there's m here. So we need to factor m out. So when you factor m out, it will be m bracket open t minus p bracket close equal to q minus n. We have to make m the subject. So we divide both sides by the terms in a bracket. So we have m bracket open t minus p bracket close, all divided by t minus p equal to q minus n, all divided by t minus p. Now from here, since this and this are the same, this one cancels this one. We have it m equal to q minus n over t minus p. This becomes our final answer. Let's take our second example. Make t the subject of the relation. We have the relation to be v equal to u plus at. To make t the subject of this relation, we have to group terms containing t at one side of the relation. So there's t here, there's no t here. So we have to subtract u from v since it is positive. So we have v minus u equal to at. Now since we have to make t the subject, we divide both sides by a. So we have v minus u divided by a equal to a t divided by a. There's a here, there's a here. So this a cancels this a. And we have v minus u over a equal to t. Or t equal to v minus u over a. This becomes our final answer. Now let's move on to relations involving brackets. When there is a bracket in a relation, we first expand to remove the brackets. Now let's take our first example. Make p the subject of the relation. We have the relation to be 3t plus pq equal to 2 bracket open p plus l bracket close. As you can see, there's a bracket in this relation. So we first have to expand to remove this bracket. Now we have 3t plus pq equal to. Now to remove this bracket, the term outside the bracket will multiply each of the terms in the bracket. So 2 times p will give us 2p. 2 times positive l will give us positive 2l. Now from here, we group terms containing p at one side of the relation. So there's p here, there's p here. So we group them at one side of the relation. So we have pq. This one can become minus 2p equal to 2l minus 3t. We subtract 3t from 2l since it is positive. Now since there's p here, there's p here, we factor p out to give us p bracket open q minus 2 bracket close equal to 2l minus 3t. From here, We divide both sides by the terms in the bracket. So which will be P bracket open, Q minus 2 bracket close, all divided by Q minus 2 equal to 2L minus 3T, all divided by Q minus 2. Now as you can see, this and this are the same. So this one cancels this one. Therefore it's P equal to 2L minus 3T, all divided by Q minus 2. Therefore this becomes our final answer. Now let's move on to relations involving fractions. Whenever we have any relation involving fractions, we first multiply each term in the relation by the LCM of the denominators. Now let's take our first example. Given that L equal to 2R plus 1 over 2 power R, make power the subject of the relation. Our given relation is L equal to 2R plus 1 over 2 power R. We are to make power the subject of this relation. But looking at this relation, there is a fraction. And whenever there is a fraction, we find the LCM and multiply each term in the relation by the LCM. Looking at the fraction, our LCM is 2. So we multiply 2 by each term in the relation. So we have 2 times L equal to 2 times 2R plus 2 times 1 over 2 power R. Now from here, we see if we can cancel out. Now 2 cancels 2. So 2 times L gives us 2L equal to 2 times 2R gives us 4R plus 1 times power R will give us power R. So from here we group terms containing power. There's power here but there's no power here. So we subtract this one from this one. So which will be 2L minus 4R equal to power R. Since we have to make power the subjects, we divide both sides by R. So we have 2L minus 4R all divided by R equal to power R divided by R. Now there's R here, there's R here, so they cancel out. So this one cancels this one. So it's left with 2L minus 4R all over R equal to power. Now this can also be written as 2L over R minus 4R over R equal to power, which R cancels R, so it's left with 2L over R minus 4 equal to power, or power equal to 2L over R minus 4. Let's take our second example. Make U the subject of the relation 1 over F equal to 1 over V plus 1 over U. So we have our relation to be 1 over F equal to 1 over V plus 1 over U. We have to make U the subject. And as you can see, it's a fraction. And whenever that we have a fraction, we find our LCM and multiply each term in the relation by the LCM. Now our LCM becomes F, V, and U. So we use F, V, and U to multiply each term in the relation. So we have F, V, U times 1 over F equal to F, V, U times 1 over V plus F, V, U times 1 over U. From this place, we cancel out. So there's F here, there's F here. So this F cancels this F. There's V here, there's V here. So this V cancels this V. There's U here, there's U here. So this U cancels this U. Now we have VU times 1 gives us VU equal to FU times 1 also gives us FU plus FV times 1 gives us FV. Now we have VU equal to FU plus FV. We are to make U the subject, so we group terms containing U at one side of the relation. So there's U here, there's U here. So we group these terms at one side. So we have VU, this one is crossing, so it becomes minus FU equal to FV. Now from this place, there's U here, there's U here. So we factorize U out. When you factorize U out, it will be left with V and F. So we factorize U out and we put what is left in a bracket. That's V minus F equal to FV. Now since we have to make U the subject, we divide both sides of the relation by the terms in the bracket. So we have U bracket to be V minus F bracket close, all divided by V minus F equal to FV divided by V minus F. Now this and this are the same, so this one cancels this one. It will be left with U equal to FV over V minus F. Therefore, this becomes our final answer. Now let's look at relations involving squares and square root sign. Whenever a relation involves a square root sign, we first square both sides of the relation to get rid of the square root sign. For example, when you have root of A equal to B, there's root sign over here. So to get rid of the root sign, we have to square both sides of the equation or the relation. So we have root A squared equal to B squared. Therefore, the square over here cancels the root sign, which will be A equal to B squared. Let's take our first example. Make G the subject of the relation T equal to 2 power root of L over G. Now we have our relation to be T equal to 2 power root of L over G. This can also be written as T equal to 2 power times root of L over G. Now, there's root sign over here. So first, you have to get rid of the root sign. And to get rid of the root sign, we need to square both sides of the relation. So it will be T squared equal to 2 square power square times root L over G all square. Now, the square over here cancels the root sign. So it will be T squared equal to 2 raised to the power 2 gives us 4 power square times L over G. Now from here, we multiply 4 power square by L over G, which will give us T squared equal to 4 power square L over G. Now there is a fraction. Since there is a fraction, we find our LCM. So we multiply each of the terms in the relation by the LCM. So our LCM is G. So we multiply G by each term in the relation. So which will be G times T squared equal to G times 4 power square L over G. Now G times T squared gives us T squared G equal to 4 power square L. So we have to make G the subject of the relation. Now there's G here, but there's no G here. So to make G the subject of the relation, we divide both sides by T squared. So we have T squared G all divided by T squared equal to 4 power square L all divided by T squared. So T squared and T squared cancels out. So we left it G equal to 4 power square L over T squared. Therefore, this becomes our final answer.